this lesson, we are going to be converting quadratic functions from one form to another. We have already done this in individual lessons, but we're now going to put all types of conversions together in one lesson with all three forms at once. So just to review, standard form, vertex form, and intercept form, those three general equations are given at the top. Let's jump right into example 1. We're given y equals x squared plus 10x plus 1, which is standard form. And we want to convert to vertex form. So to convert standard form to vertex form, we can go ahead and find the vertex. With standard form, we do opposite of b over 2a. Negative 10 over 2 is negative 5. Plug a negative 5 in for x. So we have negative 5 squared plus 5 times, 10 times negative 5. And then plus 1. So y equals 25 minus 50 plus 1, which is negative 25 plus 1, which is negative 24. On problems when we're graphing, we usually don't see numbers this big or this small because it won't fit on the graph, but we're not graphing here. We just have to identify the vertex, so negative 5, comma, negative 24. And in vertex form, I know my a is 1, looking at the equation in standard form. So y equals 1, I don't need to put there. Then I'd have x plus 5 squared minus 24. Next problem is also in standard form, but instead of converting to vertex form, now we're converting to intercept form. Remember, this is where we factor. So what multiplies to negative 16 and adds to 6? Positive 8 and negative 2. So y equals, my a is 1, x plus 8 times x minus 2. And then it says to find the zeros. Usually we were asked for x-intercepts, which we write as ordered pairs, but if we're asked for zeros, we just write as x equals negative 8, x equals positive 2. And that's it for example 2. So we started with standard form, converted to vertex, started with standard form, converted to intercept form. Now we're starting with intercept form in number 3, and we're converting to standard form. So all we're going to do here is multiply those binomials together, or in other words, FOIL. So if I do x times x, I get x squared. The outer is plus 4x. The inner is minus 5x, and the last is minus 20. So y equals x squared minus x minus 20. All right, example 4 is starting in vertex form. We have a vertex of negative 3, 1. We want to convert to standard form, just like we did in part B. So same thing, we're going to multiply x plus 3 times x plus 3. So that would be x squared plus 3x plus 3x plus 9. If it helps you to write it out twice, feel free. X plus 3 times x plus 3. And then don't forget the plus 1 at the end. That's a big mistake. Combining like terms, we have x squared plus 3x is 6x. Plus 9 plus 1 is 10. So that is example 4. So in example 3, we went intercept to standard form. Example 4 was vertex to standard form. Notice in every example, we either started or ended with standard form. So we won't ask you to go from vertex to intercept or intercept to vertex, although you could do that. You would just have a couple extra steps. It'll always either be standard form to one of the others or starting with one of those others to standard. All right, last example is looking at a graph that is already given and trying to write out that function in all three forms. So we usually were given the equation and had to graph it, but we're working backwards now. So let's just look at this graph and see what information do we have. We see that it's opening up, so we know that A is going to be positive. We see we have intercepts at 3, 0 and 5, 0. So that'll help us with intercept form. We can also see we have a vertex at 4, negative 1. So that should help us with vertex form. So if we start with vertex form, we're going to have y equals, and then parentheses squared, and the parentheses will be x minus 4 squared, and then we have a minus 1. All right, next if we look at intercept form, with intercepts of 3 and 5, we'd have y equals x minus 3 times x minus 5. Now, to get standard form, we can go back to vertex or intercept form and then just convert them. So it's probably easier to just convert the intercept form. I'm actually going to do the vertex form and intercept form just to check and make sure we get the same thing. So if I start with the vertex form, x minus 4 times x minus 4 minus 1, that would be x squared minus 8x plus 16 minus 1, which is x squared minus 8x plus 15. And if I were to FOIL part B, I'd get x squared minus 5x minus 3x is minus 8x plus 15. So same answer. So you don't get standard form directly by looking at the graph, but you can get vertex form using the vertex, intercept form using the intercepts. Notice it's opening upward, so our A, our initial value, is positive. And then standard form can be found by converting either part A or part B and multiplying everything out to get it into standard form. What you should be careful about is that if you had a graph that was opening downward, then remember your lead coefficient would be negative. Okay, but in this one it was opening upward, so it's positive. And it's not wider or narrower at all, it goes up 1 over 1, so we know that A is just a 1. All right, so this concludes our lesson on converting quadratic functions from one form to another. And then we also had this final example on writing all 3 forms out given a graph.